The week, August 2nd. Unbelievable. 3 weeks till school starts. I saw.
Oh.
Drive safely, defensively, and courteously this week. Tom sent out an email of a fellow contractor had a pretty bad accident out there on the roads. It's one of our biggest exposures out there, so it's really focus in this week and at all times. Every time you're behind the wheel, really try to set yourself up for success by good following distance, going the speed limit. It's a lot harder these days. Everybody's going faster and faster and driving closer and closer together. So try to set yourself up for success by driving defensively and courteously out there on the roadways. Ben Dow, anything more to add on our code item this week?
Yeah, all of our vehicles are a big billboard, and people always want to blame the other driver. And when we're out on the roads, we don't have control of like the environment like we do on a job site. And you're right, it is a big exposure. So I noticed this morning some other contractor trucks, and I was going 65. Everyone always says I go 50, but I was going 65 this morning, and they were going 75, 80 miles an hour this morning passing me. And it's just slow it down. It's okay. We're getting paid.
So, excellent job this past week. We're able to add 7 both to our recordable and first aid. We did have a minor fender bender system, a vehicle incident, so that day is at 2. So good job this past week. Again, like everything, it's well thought out plan, thinking about things before we do it and don't take unnecessary risk out there. Any safety shout outs this week, Tom, or anyone out there?
Yeah, so up in St. Albans at the AOT garage, Marcos Carter witnessed a car accident that happened, and he went over and rendered first aid to one of the people involved. So good on Marcos for doing the stand-up thing and the right thing to do at the right time. So
Nice
Cool.
job, Marcos.
Good.
Utilizing that training. So this week we're going to highlight lifting with chain slings. We did synthetics a couple weeks ago as we're going through kind of our rigging series. Very similar to synthetics, just like with chains. We need to know the working load limit of the chain. And again, with all rigging, you need to know what you're picking, the weights, and you want to make sure that our rigging it exceeds what we're picking. So make sure we have tags. Again, that should say the size, the grade, the load rating, and the length of the chain. If you can't read it and you're unsure what the chain is, we can't use it. So take it out of service, come back in with Elliot or ourselves, and we'll switch it out and get you some new chain slings. Biggest thing, inspections. Tom and I are going to do a more comprehensive annuals that we go through and double check everything. But again, everybody should do a kind of a quick little review of your chain slings before you do any picks. So look for wear, defective, cracks, breaks, discoloration of excessive heat, potentially, especially on the hooks, twisting. You'll see links and hooks twist, especially for side loading. So check out for that. If there's pretty much, Jim Laughlin kind of always said it best, when in doubt, take it out. If there's any issues or you're second guessing a chain sling, just take it out of service, get on the horn, and we'll replace that chain. We always got plenty of 10-footers here in stock in the tool crib. Again, it's always that 10% wear. We have gauges to check the links. Tom and I are going to be going out and doing that and just verifying that again, or you can bring them into the tool crib, and Elliot and Bill will also kind of go through a thorough check. Usually we kind of do it kind of more the tail end of the season, but again, we're going to kind of start it early because we have a lot of chains out there. So best practice with chain slings, try not to ever shorten it, tie it, pretty self and where we kind of have our biggest problems where we're snapping chains is doing stuff under tension. We're pulling something out of the ground that's stuck, or we got a trench box or road plates that are kind of buried in the soil and we're trying to lift them up, and we kind of pull them, do a jerk motion with the excavator stuff. These chains are not designed to be under that much tension. It's meant to be suspending a load just by gravity, not getting stuff stuck. So side loading too. Anytime you side load a hook or a chain, you're really compromising the integrity, and that's when we see chains snap. And it's a very violent, dangerous situation when we have alloyed metal shards flying through the air. Someone can really get hurt badly. So those are the type of unsafe acts that we need to eliminate so we don't break chains out there. So really think about what we're doing before we do it and make sure we got the right tool for the job. If something does change in the field, that we're not just grabbing a chain and trying to pull something out of the ground. So avoid any twisting or links. It's the same thing. That's how easily, if it's really twisted and then you put it under tension, easy for these alloy chains to become defective and get compromised. So proper care, again, these should be hung up in a dry environment. That's why we have our tool trailers out there. So again, not in the back of pickup trucks. It's fine like day to day, but if you're not utilizing for a while, let's get them up high and dry and into tool trailers. Or back here at the office, we want to try to make sure that our chains stay in a decent condition. When it becomes a lot of rust, again, that moisture and that rusting of the alloy chains can really compromise our chains. So we want to make sure it's kind of free from the weather, the effects of weather, especially if it gets really muddy. It doesn't hurt to power wash them down and hang them out to dry. So some quick little cautions and just best practices with all rigging, but chain rigging as well. Again, never pass underneath a suspended load. Never stand in the line of fire with a chain when it's under load or any tension. And then sure, all body parts are not between the chain and the load. We've had a couple, not really with rigging, but with binding our chains down. People fastening equipment onto a trailer, binding it down, putting our hands where they shouldn't be, and then it's under tension and in the creating those pinch points, putting our hands in between a movable object and an immovable object. So some things to consider this week. But again, let's just follow those best practices, inspect, making sure that you have the right tool for the job. And if you don't, let us know. We'll hopefully get you what you need for all the safe rigging that we do each and every day, all the different types of jobs we have going on. Is there anything to add, Tom, Ben, Ken, on chain safety?
Just a couple things. One thing that I've been noticing is guys aren't necessarily being taught the right way to hook the hooks, especially on trench boxes when they're lifting them up. So make sure that if you have newer guys on your job site that you're showing them the proper way to have the hook facing out, so that way it's not going to break the hook. The other thing is we've been replacing a lot of latches on the hooks, so just be preemptive, and if you have a hook that needs to be replaced, just let us know in advance. That way I'll usually have 3 or 4 PL5 hooks or clasps with me, but it's always that we're running out before we get to the different jobs. So make sure if you have some that need to be replaced that you let us know and we'll come out and do it for you.
Yeah, don't side load the hooks.
That's
part of the training.
Okay.
Well, that's all I have.
All right, good. My connection seems a little sketchy here, so hopefully I can continue. I will get to the ECI focus of the week. There we go. All right, do you see my screen?
Yep.
We have it.
Okay, good. Lifting with chain slings. Just a quick announcement that this morning is the August 2nd. It's August 2nd already. Meeting with our Morgan Stanley financial advisor. So if you have a meeting set up, don't forget to be there for your appointment. And I don't know if there's any openings available at this late time, but you could always check. Also, here's an important one on the Champlain Valley Fair tickets. We need to get your request in by next week. We had some trouble kind of coordinating it this year, but we're still making it available. So we need to get those in by Tuesday, August 6th. They're always wanting them well in advance. And initially they said we missed the deadline, but now we haven't. So here's your chance. So check with Sarah. You can get 2 adult tickets, and also we're adding 2 children tickets if you want. And this week we're talking about the VTrans Richmond project, and I should have Phil and maybe Ben on.
Yep, we're here.
Okay, you want to take over the screen, or how do you want to do this?
We'll read along. You can scroll, Ken. If for some reason you have a connection problem, we'll take over.
All right.
All right. So ECI was contracted with VTrans to replace and then remove Bridge 29, which currently carries Route 2 over I-89 just south of the Richmond Village. The project will replace the existing 8-span bridge with a new 2-span off-alignment bridge. The existing structure is an 8-span rolled beam structure constructed in 1964 with a curved alignment. It is approximately 497 feet in length and 35 feet wide. The deck on the new bridge will be approximately 14 feet higher than the old bridge at the west abutment and 62 feet further north. In the previous project highlights, we discussed mass earth moving, various excavation support system, construction of the cast-in-place retaining wall, abutments, pier stem, and pier cap, paving, MSC wall construction, and utility work. Today, we will highlight the construction of the steel superstructure for the new bridge. Before we can erect the 2 358-foot long steel plate girder spans, we needed to construct crossovers, putting single lane traffic in each direction into the barrel on the interstate.
So the crossovers weren't designed as part of the contract. You could use them. You were allowed to use crossovers, but it was up to the contractor to design them and implement them, from traffic control to curve geometry and tie-in points. So rather than closing the interstate, we elected to use those crossovers, and we worked with a subconsultant to design them. The construction of them required heavy earthwork, paving, and a very careful approach to traffic control, including safety marking, removal, replacement, temporary striping, and wall barrier. So once they were built and paved, we worked with L&D to remove existing striping and restripe and deploy just under a mile of Jersey barrier.
Oh, lost the screen here. Tried to shrink it down to make things fit better, and
You can just stay right on the pictures if you want, Ken. We got the words up on our
okay, all right.
individual screen, so you can just stay right on the photos.
Let me get back to it here.
There you go.
Quiet. Okay, here we go. Okay.
All right, one more, please.
Okay, you got it.
Perfect. By contract, ECI has 60 calendar days. Oh, do you want us to do it, Ken? Or
Yeah, if you want to take over, you can.
I'll share.
All right.
You guys see that?
Yep.
All right. By contract, ECI had 60 calendar days of allowable crossover used for steel erection. We spent countless hours of bid time, and after looking at steel erection on this project, the tight site, maintenance of traffic, and steep grades, and the super elevation of the road, and the heavy picks, it all presented an extreme challenge. And that required several very large cranes. ECI elected to retain CCS out of Morrisville to erect the steel, while CCS retained the bolting and splicing and the cross frame installation.
ECI did the bolting and splicing.
Yes. Yep. Once the interstate was closed, ECI went right to work building crane pads in accordance with our erection plan. So there you can see the guys putting out Jersey barriers. They got efficient at it. We put approximately 4,000 barriers down in 2 days. So just 2,000 linear feet of barrier a day, which is required a lot of support from our trucking guys, and they did a great job moving all those barriers in from Bushy Pit.
Once we started getting the crane work on paper, even at bid time, and then after, like Phil mentioned, it just became obvious that we would need, two 275-ton ATs and two 200-plus-ton crawlers. Basically, all of CCS's big cranes, which you can rent some of those, but it was just a no-brainer to bring those guys in on a lump sum basis and have them take care of the heavier picks while while we could keep the overall lift direction and an actual erection scope. Here's the guys building one of the pads for the AT. The curve of the interstate there, it's got some pretty aggressive super elevation. You don't always notice it when you're driving through there. At speed, that's the point, is it's supposed to feel good. But when you're standing there, it's nowhere near flat. And it's a really tight site. So the crane pads, even on the asphalt, were extensive, with several feet of blocking tapered down to nothing, to keep the crawlers level and in the right position on the asphalt. So the heavy curved girders are 7 feet tall, 2-foot wide flanges, of various thicknesses. And the heaviest ones weigh up to 77,000 pounds each, before any splices are made or cross frames are deployed. And the curve of those girders makes them inherently unstable. So those girders, just with that curve, if you were to set them on perfectly level blocking at each end, they would tip. They wouldn't. It's not that they might tip; they absolutely will tip, because the center of gravity of those beams is outside, their own internal support at the end. So even just placing them on the ground was very challenging. So what that required was erecting that first big span, which cantilevers over the pier, as a double. So using girder stands that prevent them from rolling, we built the first and heaviest section as a double on the ground, with intermediate cross frames, so tied together, and then hoisted that with the two crawlers into position in a tandem pick. That was using CCS's 298, which we've seen on our projects plenty of times over the years. So the 250-ton crawler and then a 200 sitting in the interstate. And ECI obviously built and engineered all the crane pads for the job. Here's the double built on the ground. You can see the big spreaders on the left side where the 250 or the 298, 250-ton has already got its girder, and getting ready to grab the other girder after we get a couple more cross frames in with the 238.
The hoisting, the double and tandem, this is that first pair that we made on the ground. The site was tight. The existing bridge is only 60 feet off alignment of the new bridge. The girders are obviously much longer than that, and room on the interstate was limited, especially with how close the cranes had to sit to the girder. So here you can see we had to kind of compromise between setting the cranes close enough and having the girders also not be under the bridge. We ended up having to put them underneath a little bit, and it was a tight tandem pick to get both high enough to get out of the stands and still stay underneath those girders right there.
So that assemblies with the cross frames and rigging is over 160,000.
Here you can see once they've tandem picked it up, it doesn't uniformly overhang that pier. So that towards the west, there's a lot more of that girder. And yeah, that's it sitting on its spot. The crawlers, they held the double right on its marks. It wasn't stable yet. Like I was just saying, the west cantilever is much greater. So they had to continue holding it. These are the B girders, while two other support cranes flew in the A girder series, and then installed 50% of the cross frames.
So here behind this first A series girder, you can see a 275-ton hydro, which is tucked really tight. His swing radius, his counterweight's almost hitting the old bridge, tucked really tight in there. Pretty substantial cut to get him into the bank far enough. And he actually picked that A series girder off a stretch trailer sitting on Route 2 and then swung that into position. So now we have one continuous line of support from abutment 1 to abutment 2. The crawlers are still holding. Now he's going to hold. ECI makes the splice in the air. So that's, a full flange, and web splice with, I don't remember how many bolts, hundreds of bolts. I don't know if Brad's on or Phil, if you know off the top of your head how many bolts the splices had.
Brad, I do not know. I know
A
it was
lot.
75 just in the web, and then yeah, over 200 probably between the web and the flange.
So here's the last one. So yet another big hydro. I think it's technically a 265-ton Liebherr. Grabs that last A series, well, the last to get stability, the 4A series girder, picks it off the interstate very carefully without knocking into it, hits, swings the 4A. We make up the last place, and now we've got stability. Now we've got a full double set hanging off over the pier, but also sitting on abutment one. So now we've got stability. Once we get 50% cross frames in there, the cranes can let go. So obviously this is an operation that it needed to get done, that, we couldn't leave, obviously, right? We can't leave these very, very high suspended loads in the air. I mean, I guess the crane operators could have slept in the crane, but this was important to get done in one day.
That right there is the ultimate threading the needle picture. This is us erecting the cross frames for the A series, and with our own 138, we have 160 feet of boom for it now. We have to boom right between the boom tips of the two hydros and the rigging, just to land those cross frames in there. Nick Peck did an incredible job guiding those in, and he even had to back up a little bit and then drive ahead just to miss their rooster shivs at the top.
A lot of booms in the air, and you can see our guys walking the iron to land those cross frames.
Here the guys are making that connection.
So for access, we had one closed barrel, so we had between all the cranes on the ground, maybe not a ton of access, but some access from the ground with lifts. Otherwise, we use splice cages, these metal cages. They actually just set on the girder and the guys can safely work in. So between splice cages and baskets, we were able to get safe access with fall arrest systems in place to do the work. Here's Malcolm Forrester giving Nick some tips and pointers on his crane work while the Forrester family looks on.
Malcolm was there for that critical pick, right?
Mm-hmm.
I think he was the lift director.
Yeah.
So with day one in the bag, you can see the double all set in the background. Here's Phil doing some hook work ahead of the next step. So now that we've got that big double in, the AT cranes can leave and the crawlers will each erect one beam while we make the splice in the air and continue to fly cross frames in. So now it gets quite a bit simpler. Still tight, but now we can do a B and an A, splice it, cross frame it, and then keep going for all 5 girders for phase 1.
So once all 6 girder strings are in, we finished up all the cross frames. Like we were saying, we had to do 50%. So every other cross frame had to be in, which allowed us to both accelerate the erection and then come back later when there was less booms in the air, less threading of the needle, so to say, and just slam out putting in those cross frames. The bolt torquing was about roughly 700 foot-pounds that was needed. Occasionally there was a little bit more, but we used special DTI washers, which direct tension indicator washers, to let us know when we achieved the appropriate tension and the clamping force that was needed.
So the way all these connections work in pretty much any modern steel design is not to, have the bolt take any shear. The bolts themselves aren't side loaded in what you call a bearing type connection, but it would be, what's called a pre-tensioned, maybe slip critical connection, where you're actually, what's holding these connections is actually the friction between the plies of steel, and you're holding them so tight that the steel is making a mating surface or a fading surface that can't slip. So that's why the tension and, the actual mating surface and the preparation of the surface is so critical. So we calibrate our torque wrenches We use electric and battery powered torque guns to do it, and we calibrate those with a Skidmore. But then we use these direct tension indicating washers, which do squirt out a little orange silicone, which is a visual aid to help us see when we're getting close. But we actually have to use feeler gauges. They have little nubs that will squish slightly. So you use feeler gauges to see how many penetrations you can get. And I think we're generally allowed up to 2. And any more than that, it's not tight enough, and we have to keep going. It is very I want to say tedious, but it's a fine line because you have to get them really tight, but you almost snap them essentially. So when you're just trying to go for that last little bit of tension to get that DTI, fully engaged, it's pretty common to snap bolts and have to go back and replace them.
IPS, right, Mike? They're it.
So after phase 1, we moved over to phase 2, which was the all traffic on the southbound barrel. That required the guys to again pick up all 4,000 plus of those Jersey barriers. Sorry, 4,000 linear feet of those Jersey barriers and put them in the other lane. They got that done again in day and a half, which is just an unbelievable amount of work from those guys. They were really flying. And now traffic was in this current configuration, which I'm sure some of you have driven through, and we were getting ready for phase 2.
So phase 2 was simpler in one sense because we already had steel structure there. We didn't have to set a double, but the next beams, because they weren't spliced in the air, they're spliced on the ground. They were the longest, individual spans. So you have now a C and a D series girder, which are lighter, but making up 150 feet. They had a real, on paper anyway, a real propensity to buckle under their own load. So what we did is CCS brought back in another AT. We made the splices on the ground for these 150s. I set those with an 85-foot spreader beam, which is extremely long. Set that and then fly the next 2 in, one on each crawler, make that splice in the air, and then set cross frames.
And that spreader beam being as long as it was kind of looked like under its own weight, just a smiley face. And it was engineered, but definitely everybody was weary of it. But it worked.
You can see the crane pad here. This location had, I think, more super elevation than where we were in phase 1. So a pretty substantial crane pad to hold that crawler.
Yeah, and they were tricky to build because the road both slopes has a slope laterally and down the hill as well. So took a lot of finesse and messing around trying to get those crane pads built just right. And the key is, you have to be within a certain radius to set your steel, but you also need to keep backing up because as you set the steel, you're getting closer and closer to your crane. So the crew spliced the C&D girders on the ground in their support stands with the crawlers, and then they would fly them up as a pair. This first piece was flown up just with that 85-foot spreader, and then after that, those 2 crawlers just individually with tandem pick each beam, fly it into place. And I'll show you that. I got time lapse to show how that kind of went together. So there you can see C and D 5 and 4 are up and in position, and the crew is working on their cross-frame connection.
Here's the steel all up, all the beams and cross frames, and the proud team that built it standing in front. Pretty picturesque sight with Camel's Hump in the background. And there's our new 500 there in the foreground, which has been pretty handy. And our 138 sitting in the median.
And then here we've got 1 million pounds of American steel and a flag bigger than Ken Allard's flying right over the project. Just every day when we fly it up, they honk as they drive by. So it's a proud sight and something great to be a part of. I've got a
You gotta
couple
give all
of.
the credit on the flag, Phil.
Sorry about that.
You got to give all the credit on the flag.
Yes, that's true. That I do. Thank you, Ken. Ken did find that flag on Craigslist. It was a steal, and I've since. Yeah,
What are the dimensions?
I think it's a 25 by 40. Yeah, it takes a full team to put that away properly.
Tandem picket.
And it belongs to Matt Procto right now. He did cough up the money for it, so he gives me a hard time about that. I've got just a couple time lapses real quick to put into perspective, and then this is the right one. There you go. I don't know how these always come across kind of weird. It's choppy anyway because it's a time lapse, but here is the 5 and 4 the 5 and 4 B girders being spliced together on the ground in their paired connection, and then in their stands. And once those are erected, the two crawler cranes will swing around with different spreader beams to pick those up, and it goes a lot quicker than it felt at the time. There's Brad getting it set right on top of the bearings, just the way we like it. The Grove right here picked the A5A girder off Route 2 and flew that into place, and now you can see the team in here making that connection. It's got hard to see from this angle, so I got another one. This is post the 5 and 4 erection, but here you can see 3B coming in and 3A, and that is how that connection is made. They make the splice, keep it a little off level, but it allows them to swing it in properly. They pick it up in tandem and then set it on their bearings. This happened 3 more times after that, and you can see the guys flying the cross frames in to make all those connections as well. And then from a closer shot, here is span 2, or phase 2, so to say, and this is us assembling the C and D girders on the ground. This was actually right during the Royalton shutdown, so CCS was eager to keep going, and after some delays due to submittals, they felt that it would be right for them to help out and make these connections while we were in Royalton, so that when we came back on Monday morning, we were ready to go and then fly these girders right into position. So that effort was really appreciated. So those are sitting in their stands; they're not paired together. And then here, this is the tandem pick by the cranes, flying those right into position. Again, it always seems faster in these videos. It's unbelievable. We're using our new JCB lull to fly cross frames in. We had a hard time getting our booms past each other, so we used our lull without forks on it to lift each cross frame into position. And under here, you can see the guys. Like I was saying, the crane pads had to be moved because the bridge kept getting closer and closer to the crane. So here you see the guys working on building a crane pad while steel erection's taking place, and that allowed that crane to back up just a little bit further to set then that final girder, which happens later on. Yeah, so that is steel erection enrichment, and right now the guys are working on putting in deck pans and overhang brackets. We've got the concrete guys here and the steel guys, and yeah, next time we'll present probably be once the deck is on.
Perfect. Nice job.
Nice pictures.
Thank you.
Great presentation. But do you want to cover the archive photo?
Yes. 1 second.
Okay.
Sorry.
Throw it up if you.
I'm almost there. Do you have it? I got it here.
Oh, boom! Beat you to it.
There's Gene
Yeah.
the Machine using a hydraulic track wrench and a skidmore to
That's awesome.
do those bolt tension and calibrations we talked about. You're correlating a tension. It doesn't matter. Torque can be influenced by, the threads, whether it's galvanized or not, how much wax it has on it. And so torque can vary, but what's important is tension to get those steel plies clamps together like we talked about. So we use this Skidmore device to correlate tension to torque and set our guns. We don't really use hydraulic track wrenches anymore for this, but 14 years ago, that's what we were doing.
It's cool.
Yeah, for sure. All right, good. Thank you very much, guys. Let's turn it over to the safety department.
Yeah,
Hey, I got
excellent.
I got something, Matt.
Go ahead, Ben.
I want to thank everybody that participates in this meeting. We're really busy right now and it's hard, I know, for everyone to plan to do this, but I think it shows respect for our culture and it just a weekly discipline of honoring that safety's our highest level priority, because it's really easy to flip those priorities around when we get busy. And that's when things happen and people get hurt. So I want to thank Ken and Scott for allowing us to do this every week. We pay everybody to do this meeting, and I think it's important to our culture. But always remember that we appreciate, and I appreciate everyone being on here for this half hour. So thanks. Keep it up.
Thanks, Ben.
Definitely a key part of our culture for sure, I think.
I think it is.
And it's
you.
great to have the guys participate and present here. I think that makes it special too.
Yep, it does.
Well,
Okay.
on that note, if you watch the group setting, please send over attendance so you can capture it. We have it recorded. We'll upload it to YouTube here shortly. See those emails come through. Looking like a great day. It's a great day to make good decision and work safe. Let's have a great day, guys.
Okay, have a good
Yeah.
one.